Yeah. Yeah, what you got? You got something? Let me see. Hold on. Sorry. So, based on what was said earlier, what was your name again? Shelby got something to work. Shelby got one of the answers. Did you get another one? You got something? Okay. Wait a minute. Oh, there's a one in this corner. Okay, this is okay. So this is okay. I got you. Is this a 5 and a? Oh, that's a 3 and a 3. Okay, you got it. Cool. And is yours different? No, yours is the same. So, let me give you a little bit of help. There was a comment made earlier about the corner numbers being important, and they can't be too big. So maybe instead of doing random guess and check, which I don't think anybody did, random guess and check. Have you guys all heard guess and check? Yeah. The book calls it guess and test, which is weird. I've never heard of that. But guess and check. It would just be 1, 2, 3, 4, 5, 6, and then seeing, and then just going crazy. I don't think anybody necessarily did. Maybe in your first go you did just to see what the hell would happen. Yeah. Then there's something called systematic guess and check, which is where you're a little more aware of what you're putting where. There's a system of what you're trying, and then the ultimate level is inferential, which is stepping back, not putting shit in there, and noticing something like the corners are going to be important because they're used more than once, correct? So if we do put the smallest numbers in the corners, what do I have so far in this row? 5. So I need 2 numbers here to add to be, if this is 5 and I need 17, I need 2 numbers to add to be 12, correct? All right, so I need these to be 12. I need, so far here I got 3, so I need these to be 14, and so far here I got 4, so I need these to be 13. Do you guys see that? Yeah. This is inferential guess and check, which is where you actually think before you do something. And you realize, oh, the corners are important, so let me try putting the smaller one. You might try the bigger ones first and go, well, that's going to be shit. The biggest one, 9 and 8, already make 17, so you're screwed. So you're like, let me try the smaller one. So you guys kind of with me? So again, I know you all know the guess and check approach. Have you guys, before we finish this out, in algebra class, word problems, did you ever get the answer and the teacher still said, well, you didn't show algebra? Does anyone remember this? Okay, all right, I love it. So my example for that when I teach algebra, in which case I can't anymore, I don't know if you know this, but it's illegal for me to teach algebra in community college in California. Yay, go legislature. Okay. Real quick, there were 2 bills passed, 705 and 1705. Effectively, we used to teach a class called Math 110, which is intermediate algebra like Algebra 2. We're not allowed to teach that anymore. We used to teach Algebra 1 here, and I had a lot of success with students, and I loved that class. I'm not allowed to teach it anymore. Pretty soon, pre-calculus is going to be killed also. So if you want to major in a STEM field, you have to start with calculus. And then they say, how do we get more STEM students? And I'm like, are you listening to yourself? Anyway, sorry. A lot of rants in me about that, so I'm going to go away from that. If you're curious about that, it's AB 705 and AB 1705, made by people in the legislature who don't know math. Yay. Okay. Coming back, I'm sorry. Let's see if I remember what the hell I was talking about. So now we're doing this inferential approach, right? I forgot what I was talking about right before that, but I need 2 numbers that add to be 12 here. So how can, oh, good. Yeah, so if you use 5 and 7, let's see, 5 and 7, can I make 14 with something left? 8 and 6, and then I need to make 13. The only things I have left are what? 9 and 4, and they make 13. Kick ass. All right. I like it. Okay. Can't remember the other one. There's another. It might have just been a rearranging of this. I can't remember. Okay. So I need you to be with me on this. We're about to get into chapter 1, which again is related to students' most favorite thing. Now stop being sarcastic. The least liked thing is word problems. Am I wrong in that? If you remember your word problems. And one reason they suck so bad is because they didn't make sense. Some dude forgot how much money he put in the bank. I'm like, who is this person? I got 2 accounts. How much should I put in there? It's like, what a great problem to have. I know exactly how much money I put in the damn bank. Anyway, sorry. Or is a question like the thing, I can't remember if I put it on here about Sally from Peanuts saying, only in math can you buy 60 cantaloupes, and nobody wonders what the hell's wrong with you. So often our word problems suck so bad. It's like, who the hell is this person? Right, I'm sorry. Just want to be ready for the cantaloupe party, right? So one reason that word problems suck is because they weren't really connected to the real world, seemingly. Although we could easily make ones that are. Another reason they suck so bad is because you had to develop your own equation based on the situation. That's not easy, right? So, not all of chapter 1 is word problems. Do you all agree with me there's not a damn thing up here that's a word problem? This is definitely not a word problem. It's a puzzle. And I understand some of us might hate puzzles. But if you just keep reminding yourself, if you had this kind of problem and you could not figure out the answer, capture your thought process. What are you trying to do? What was it that made you try to do that? That's what I'm going to give a bulk of the credit for. Are you understanding? So don't just erase everything. No, that's gold. Show me that damn work, right? You might have had something. You didn't realize it was going in the right direction, or you might have wrote something in the wrong place and then messed you up. You might have been this close. And I don't know unless you show me what you're trying to do. Are you guys kind of with me? I desperately want you to understand that getting the answer is bonus. It's like extra. It's icing. Show me your thought process. Are you guys with me? It's very human to want to get the answer, and I want you to want to get the answer, but do not get frustrated. Some of these problems are going to be a little weird. Most of them are not going to be too weird, but still, it's not going to be immediately obvious how to get the answer. Okay. So, what I want to do, this problem, I like to start with this problem because you've all seen something like this somewhere. I know you have. Has anybody ever seen something like this anywhere in the world? No? Never? Okay, some of you, yes, okay. Okay. Here, let me do this with you real quick also. Can everybody pick a number and write it down? Everybody pick a number and write it down. Up to you. You can be as crazy as you want to. Just pick a number. You with me? You're going to have to do stuff to this number, so maybe don't make it 4.8973, but you could make it 4.8793 if you wanted to. Are you with me? I would make it 3 or something. Yes? But it's totally your choice. You with me?
Oh, is this the one where like you to figure out your age?
Something like that. I want you to double the number you got. Or just sit and stare at me if you don't want to try it. Okay. Now I want you to add 10 to what you got. Is everybody with me? All right. Now cut what you got in half. And now subtract your original number. The number you started with, the number you picked. Did you get 5? Oh, I'm reading everybody's mind. All right, that's complete bullshit. So this kind of problem, that I know you've seen shit like this. You're right. Sometimes they'll say, add the year you were born and subtract blah, 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 and subtract blah, blah. You know, you're like, that's how old you were. Oh my God, it's, now on one level, I love it because I'm a math guy. On the other level, it's dumb. It's really dumb. Does anyone know how to see why? Did everybody get 5? I don't want to call you out. You should have gotten 5. If you did everything I told you to in the right way, you should have gotten 5. Okay. Does anybody know why everybody got 5? So did I tell you to double at one point and then I tell you to cut it in half at one point?
Yeah.
Wouldn't those undo each other? Didn't I tell you to add 10 at one point? And what's half of 10? So if I wanted everybody to get 6, I would have told you add 12 instead of 10. You guys kind of with me? So how do I prove that I'm always going to get 5? How do I prove that I'm always going to get 5 if I do those steps? How the shit would I prove that?
Can you input different numbers?
That wouldn't prove it. Because maybe it only works for the kinds of numbers you picked. Did anyone start with a negative number? Did anyone start with 0? See, maybe it only works for positive numbers. Maybe it only works for positive whole numbers. If I would have tried 5.5, maybe it wouldn't work. You guys kind of with me? So, real quick, I need you, just stay with me. When I'm investigating a possibility of why something works, if I use specific examples, that can never prove it. That can only get me to understand it a little bit better, right? So, if I want to prove this, don't I have to use every number? Does anyone know how to use every number at once? You've all done it before.
What's the R?
No. I know, I appreciate that, but no. No. It's nothing major. In algebra, when there's something you don't know, what do you call it? Okay then. And what does X represent? Any frickin' number. So, stay with me. Is everybody with me? Okay, I want you to at least see this once in your life. So when I say start with a number, what we're going to do is we're going to start with X because that's every number. Does that represent 4.876? Does it represent 0? Does it represent negative 1? Yeah, it represents every freaking number, Jeff. Okay. So if I start with X, so everybody write X down. Now double it. What do you get?
2x.
Holy shit. So let me see. So if you have X, double it, 2X. Now add 10 to it. 2X plus 10. Now cut it in half. Good. And now subtract the original number. Yeah, there you go. So of course you're always going to, I don't care what you start. You could have started with square root of 438. You would have ended up with 5. It would have looked gross on the way, but you guys kind of with me a little bit? So remarkably enough, this process is called use a variable. So in a situation where there could be an infinite number of things that you could use a variable instead. Because that represents every possible number. Okay, I like it. So let me kind of formalize what we're doing. I want to start with a couple examples of kinds of problems you could see. And then I'm going to kind of formalize some of the stuff. Don't use this, Jeff. Okay, Jeff. Paper. Here. Oh, I gotta move my camera. I gotta hire a camera person. So the very first method we've learned is the guess and check method. Oh, that's right. I just remembered what I was going to tell you earlier. Oh, this is exciting. My entire life, by the way, I've been absent-minded. I've been an absent-minded professor my entire freaking life. And now I'm getting older. It's awesome. So, when I told my algebra students, why is it I'm going to take points off if you get the right answer, but you didn't use algebra? Here's my example. Anybody ever took driving? Did your high school give you a driving class? Anybody? They don't do that anymore, do they? So back in my day, we had a driving class. I had 2 instructors. One of them was always drunk, which is exciting. He would say, take a right? What? Anyway, if I'm teaching a driving class, and they say your final exam is to drive to the mall, and you walk to the mall, and you call me and say, I'm at the mall, do you pass? Hell no! You got to the mall, didn't you? But you didn't drive. The whole point of the class is driving. So in algebra, if you got the right answer but you didn't use algebra, obviously it's not going to work in algebra class. Are you guys with me? This is problem solving, which means algebra is just one possible tool you could use. Are you with me? There are other things besides algebra, and we all know this. It's just when you're in algebra class, you have to use algebra. Are we in algebra class? No, good. All right, so we don't have to, unless I tell you to. So, first thing is, guess and test is what the book calls it, but I hate that. Oh, let me see. Let me get these to work. So we got guess and test. I'm going to call it guess and check, but the book calls it guess and test. And you have 3 levels to guess and test. I already put them up there. They're totally random, which means no thought at all. You just start throwing numbers in there and then seeing what's going on. That is not a bad first step, because then you can kind of see what's happening, how do the numbers react to each other, what happens in the whole thing. But normally not a very good way to get to the actual answer. It's not a bad way to start the problem. Then you have systematic, which is where you're paying a little more attention. I'll put a 1 there, let me put a 2 there, let me put a 3. You're being a little more careful. You're not just kind of like letting them tumble wherever the hell they go. So there's a system to what you're doing. And then the highest level of guess and test is inferential, which is the last thing we did, which is just stepping back, not putting any numbers in, and just thinking ahead. Oh, the corners are going to be used more than once. That could mean I've got to be more careful about the numbers I put there. Okay. When is it okay to use, when is it a good idea to use guess and check? Guess and test, whatever. So it's good to use when you have a limited number of possibilities. Did I spell right? Possibilities, yeah. Looks like a lot of eyes. That kind of makes sense. I'm not going to do guess and check if there were 80,000 possibilities. I'm not going to do that. That's going to drive me insane. Are you guys kind of with me? There was a limited number of arrangements because there's a limited number of numbers. So guess and check makes sense. Like I also said, it's good to gain a better understanding of the problem itself. So you might have a problem, you have no idea, and you start guessing and checking and just to see what kind of happens as you put different numbers in. Also, if you have a good idea what the answer is. If you already kind of know what the answer is, then it's kind of smart just to plug it in and see if it actually works and say, there you go, I showed that it worked. Of course, this is kind of silly, but it's possible to test numbers. So you have a situation where you can't actually plug it in anywhere. That's not a good situation for guess and check. Blah, 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 blah. Oh, sure. If I narrow down my choices by using other strategies first, so I might do some other strategy first and go, okay, I've only got so many things left, let me just guess and check. Okay. And then finally, my favorite one is if there's no other strategy that makes sense. So this is all guess and check, or guess and test. I am most likely going to say guess and check because that's what I'm used to saying. This is our first of 6 of processes to use. Okay. Now, so already got what they want from that? More than you ever wanted? Okay. The next thing is draw a picture. And very often in algebra, I'm going to keep coming back to algebra because that's the first place students normally hit, like problem solving stuff. If I would have a problem that would say I want to make a garden to have a certain area, and you only have so many feet of fencing to use. The first step on that kind of problem would be draw a picture, just to give yourself a visual anchor for what the hell you're talking about. So draw a picture very often is the first step in a longer problem, just to kind of feel out what the hell's going on. We drew a picture for the earlier problem, but that was just because it was using circles to fill in, right? What's another situation? Anybody imagine another situation where you might want to draw a picture to help you do the problem? Yeah.
Are you asking for like an example of a problem?
Yeah.
I think of one where it's like you have a tree and the tree is X amount tall. Find the length of the shadow on the ground.
Oh yeah. So that sounds like a trigonometry problem. Actually. Good
I
example.
don't know. It's just
Or like a Pythagorean theorem problem. You can draw the little triangle,
Yeah.
tree, shadow. Yeah. You know, like no thank you.
Not fun.
I like it. No, it's a good example. That's not one I'm going to give you. I'm not going to suddenly make you know trig. You never could trig. Don't worry. Okay. So we'll see some more examples. Let me give you a few possibilities. Immediately, the first thing I would say is if it's a physical situation. There's nothing to draw if I say solve x plus 2 equals 7. There's really nothing you can really draw that you need to draw. If there's geometrical stuff involved, just like you just said, you had a triangle, so that could use old Greek dude, Pythagorean theorem. You've all heard the Pythagorean theorem, yes?
Mm-hmm.
What does it say? In a right triangle, right? Okay. And just real quick, Pythagoras had a group of followers. And a lot of the work he got credit for was done by his followers. Just to let you know. The history of math is really, there's poisonings, duels, there's people going insane. It could actually make a pretty interesting, maybe not Game of Thrones level. Anyway. Blah, 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 blah. Oh, and to gain a better understanding, that's going to be a part of a lot of these. And, this one's funny. If a visual representation is even possible. Kind of makes sense. I'm not going to draw a picture if there's nothing I can draw, like I said earlier. I like it. So some of these processes, some of these approaches are going to be used together to solve a bigger problem. So like I said, very often draw pictures the first thing you do. And then the one we used just a minute ago. Use a variable. Does somebody remember what's a good time to use a variable? I already said one situation. Yeah.
When there's like unlimited possibilities.
Yeah, when there's like an insane number, unlimited definitely, but just an insane number of possible answers. You definitely want to use a variable. When the number of possibilities is large, especially if it's infinite, that's kind of big. If you ever see a situation where they use the phrase for any number, sort of like the one we just did. For any number, if you double it and then add 10, blah, 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 you'll get 5. If I want to prove that, I've got to use a variable. Blah, blah, blah. That's kind of silly. If they want a proof, very often you got to use a variable. Here's a big one. Okay, let me ask you this. There's still more to this list, but just deal with me. That's all we do every day. If I said that 2 consecutive numbers, okay, what the shit does that mean? Can somebody give me an example of 2 consecutive numbers? 1 and 2, 3 and 4. Yeah. So if I said 2 consecutive numbers add to be, you could do it, Jeff, 63. Could you figure out what the 2 numbers are? Yeah. Would you have to use a variable? No. You guys someone with me? Could you use a variable? Hell yeah. So if you don't know what if I know I have 2 consecutive numbers, what's the first number? No. It doesn't have to be. So this is kind of funny. Pretend like we're in algebra. I know I have 2 consecutive numbers. What's the first one? Do you know? I don't know. Do you know what the first number is? I don't know. So what do we call it? X. What's the next number?
1.
No. No. X plus 1. The minute you say the first number is X, the next number is X. So give me a number. Anybody give me any number you want. 30? What's
3.
3? Okay. What's the next number?
4.
4. Crazy. Somebody else give me a different number. 20. What's the next number? So the minute you set what the first number is, the next number must be that plus 1, correct? It can't be its own independent variable, which is what would just calling it Y would mean it's separate. Are you guys with me? I like it. And you all very exciting. Okay. Oh yeah, so that's if I use the words consecutive, even, or odd. If I use those words, that might be a good place to use a variable. Blah, 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 blah. Oh, nah. Yeah, I already said that. Nah. If they want you to develop a general formula, that's obviously a place to use a variable. Now, underneath all of this, if I use a variable and set up an equation, you have to know how to use algebra. That kind of makes sense. So very quickly, I'm gonna let you guys finish writing all that. So already got that. Can you solve this for me? Who's got that answer? You got it? Good. What'd you get? What's the first step? What's a good first step? Yeah, minus X. Minus 1, not a bad idea, because we're going to have to do that in a minute, but because the whole idea here is just get all your X's together, get all your numbers together, right? So 2X minus X, X. And then I get all your numbers on the other side, kick ass. All right. So the level of algebra in this class is not going to be too much beyond this, correct? Because you're all going to be elementary teachers, not a lot of algebra for the lower, but if you're going to teach like 7th, 8th, 9th, whatever, you're going to be teaching algebra. 7th, 8th, I guess I should say. Okay. So, let me give you this. We're not going to do all of this right now. We have today and Thursday for this. All right, guys, what I want you to try to do. What's that? I thought somebody was typing away. Wait a minute, Jeff. See? I want to see somebody bring a typewriter. That would be awesome. Mr. Waller, where'd you say there? Okay. All right. I want you to try to do the first problem. You can work with people near you. I'm not going to force you into groups. You're together with other people. You can work on yourself. Is that okay? Yep. I guess so. Very good. Now when they say 3 different methods, they don't necessarily mean like draw a picture, so, but they just mean whatever methods you can imagine trying to solve this problem. If you don't, it can only come up with 1 or 2, good. Sense. Okay. I'll be right. This is wide open. This is not algebra anymore. You don't have to use x's. You don't have to. You could just whatever the shit way comes to you. You could try guess and check until you go crazy, right? Do whatever you want to. Just try to get as many different methods. Alright, so now I'm going to force you into groups. So I want, just like before, like these guys right here, you guys turn around, work together, you guys here, you guys over there, you 4 right there, you guys here, you 4, you guys here, you 5, these guys, compare notes. Oh, can you? No. Just put one on the front, yeah. I've heard some really interesting things. There's an approach I didn't even think of, but Who's got one approach they want to talk about? Yeah.
We'll get a guess and check.
Guess and check. So how did you start it off?
Well, I kind of knew it was.
Oh.
I mean, like, I knew, like, I needed to get to 70. So, like,
Okay.
when I started at, like, 20.
Okay. Sounds like what was happening over here.
Plus 20 equals 60, and then you just keep.
Ah, perfect. So it was sort of systematic in a way. So you didn't just go 1, 2, 3,
No.
4, 5, 6, 10, 11, 12. You know, so you thought about it. I've got to get high enough up. I got to be in the 20s. I love it. That's what I was seeing over here. So that's sort of like systematic guess and check. You guys, anybody else come up with that method? Yes. Okay. Anybody else come up with a different method? Yeah.
Mine was kind of still systematic, but I divided 78 by 3 and got
Okay.
26, so I used 26 as my middle number and then picked one below and one up.
I love it. That's the way I normally get in algebra class. And that's when I get to be really dork and just say, different answer. No point. But here we're not in algebra class, so that's a perfect way to do it. I need 3 numbers. I know they're going to be off from each other by 1. So if I can just divide that by 3, it's going to give me right about where I need to be. So I'm going to get 26, 26, 26. So if I just add 1 and subtract 1, now let me say this. 26 plus 26 plus 26 is 78. Therefore, 25 plus 26 plus 27 is also 78 because it just took 1 away, yes? Okay. Does anybody else get a different approach than that? Yeah.
Just using the variables, so x plus 1, x plus x plus 2 plus
Kick
3.
ass. All right. So, now listen, real quick. I don't know if you know this about me, but I'm a math teacher. So algebra is big and close to my heart. You don't get extra credit for like using algebra, but little tear comes up. So yeah, if you call, now you're interesting, when you call the first number x plus 1,
Yeah.
okay, this is neat. So if you call the first number x plus 1, the next number has to be x plus 2, and the next number has to be, you guys with me? That represents any set of 3 consecutive numbers. You guys with me? So what if I start with 9? X would be 8. So this would be 10, this would be 11. So it represents all possible groups of 3 consecutive numbers. You with me? What do they add up to be? 3x plus 6. And that's supposed to be 78. Then you get your algebra going, right? Get your algebra on. And inherent is that division by 3. Do you see that? I'm going to have to subtract 6 and then divide by 3, which is how it's related to the approach of dividing by 3 and then going up and down by 1. Are you guys kind of with me? So this is huge. I need you to understand. I've said this before. I'm going to say this a lot this semester. Your students are going to do things in very creative ways. If you get a young enough student, they're not going to be jaded yet. Unfortunately, sometimes they get far enough and they get jaded because they get not the best teachers. They get parents that are telling them, oh, I'm never good at math. You're not going to be good at math. That kills them from the beginning. But when they're young, they just want to play with every damn thing, including mathematics, which is where we should be playing with mathematics. You guys just aren't used to it. So they're going to be doing all kinds of neat, creative shit. And if they have a teacher who's not flexible, they're going to shut that down. And then that's so sad to me. That is a potential amazing math person that we've just shut down completely. You guys kind of... So it's really important for you guys. You have got to get into a student's thought process and see what were they thinking. If they got the wrong answer, was everything about their thought process wrong? Or was there some good stuff in there and they just made some mistakes? You got to bridge to the student. So here I would subtract 6 and then divide by 3. Here's a neat trick. What's 72 divided by 9? What times 9 is 72? 8. And so 72 divided by 3 will be 3 times 8, 24. So if x is 24, what's this? 25, 26, 27. Now, quick side note. If I would have done it with algebra, I would have called the first number x, the next number x plus 1, and the next number x plus 2. I would have gotten the exact same answer as you. Because my x at the end would have been 25. So if you say x plus 10, x plus 11, x plus 12, this is going to be different, but then each of these are going to be 25, 26, 27. I don't know if you guys are with me. That's the power of algebra. It doesn't care what you call the unknown. You'll get to the same answer at the end. Okay. Was there anything else I left out? Anybody do it a different way? Okay, we pretty much hit the main ways. So I want you to look at number 2. Try to do something with number 2. This is the last one we'll do today. We'll finish up Thursday. So it's really interesting as a teacher, the quieter things are, the more indication that is that people I have like that. Most of you guys have drawn a picture. This is fantastic. Have you labeled your picture? Yes, of course. The labels are not very exciting, but they're really important. So this kind of problem, once you see it, every problem like this is almost the same. So a really good first step, draw a little rectangle. That's crazy. I'm going to call this the length and these two the width. So let me ask you this. See if you guys are cool with this. If I go halfway, isn't that W plus L? If I go halfway around it, isn't that W plus L? And what would that equal? Because they didn't go all the way around. Half of it. 29. And what's got to be true about W times L? 198. Now, let me say what this says. This says I need 2 numbers that add to be 29 and multiply to be 198. Yes? Does anyone, let me see, I'm about to lead you down a road that you never have to do here, okay? Does that sound familiar from algebra in any capacity? Related to what kind of problem? You could do it. Factor. Remember, like x squared plus 6x minus 16. 2 numbers that multiply to be 16 and add to be 6. Does that sound at all familiar when you have to factor something? You guys. If not, you're fine. You're like, dude, I blacked out that entire part of my life. Tears for a different reason this time. This is a number puzzle now. I need 2 numbers that add to be 29. And what else has got to be true? Could I have a negative width? No, if you can, I don't know if I want you to show me. Because that's like a little black hole that's going to suck meters out. I can't have a negative width or a negative length. So I know it's got to be 2 positive and add to be 29 and multiply to be 198. Would guess and test work? Yes, in fact, what we've done, didn't we do some work before we just started guessing? So this is inferential. I've set up some parameters for my guesses. I'm not just going to blindly guess. Maybe it's 100. No. Now my guessing check is more limited. Give me 2 numbers now if you've already, has everybody got the answer? Okay, hold on to it. Don't say anything. Has anyone not got the answer yet? I'm going to assume everyone else. Can anybody give me 2 numbers that add to be 29? 29, holy shit. And what's 20 times 9? We're close. So I just need 2 numbers that add to be 29 and multiply with 198, correct? Halfway around perimeter area, correct? So I can start guessing, and then I can use my guess, I'm close. What else? 13 and 16. All right, did you already figure it out? What's 13 times 16? Huh? 208? So these add to be 29, and they multiply by 208. So I went too far, right? Stop for a minute. So I took 20 down to 16 and 9 up to 13. So maybe halfway, what if I take 15 times 14? What's 15 times 14? No. 210. So that went the wrong way, right? So what if I go the other way and say, what about 18 times 11? $198. Check. So the important thing there was to realize that the problem established 2 requirements. Perimeter is about adding, area is about multiplying. Which made it inferential guess. So I was guessing, but my guesses were based on two numbers that add to be 29. They had to live within that. They weren't just any two numbers I wanted in the universe. They had to add the 29. And then I could check to see if they also multiplied to equal 98. This is basically what you did when you factor stuff in algebra, however long ago it was when you last took that course. So Thursday, what's going to happen? I'm going to have the quizzes graded. I'm going to give you guys a practice test, because what is the test? A week from this Thursday, yes. You guys with me? So like next Tuesday is going to be review day. We're not going to do any new stuff next Tuesday. It's just going to be devoted to review. All right. Let me know if you need anything. Otherwise, I'll see you Thursday. Oh yeah, don't forget your stuff, please, dear God. Thank you.
I'm just gonna